push that rock here with some math. So we have a statement here that the integral of this integrand with respect to x equals this output over here, where c stands for any real number, and we want to verify it's true. Well, if this is true, then if I take the derivative of this, I should get the integrand, because this is supposed to be the antiderivative of this. So if I differentiate this, I should get the integrand. And since I know how to differentiate well, that's what I'll do. I won't try to anti-differentiate this. This looks crazy. This is something you would study in the next class. In the next semester, we will learn to integrate this. But for now, we'll just want to verify it by taking the derivative. So what we're going to do is quotient rule. So, but before I do quotient rule, I'm going to rewrite that numerator as 5x plus 1 to the 2/3. And I'm going to think chain rule. I've got x to the 2/3, but I got a 5x plus 1 stuck in. And then down here, I have 2x plus 3. And I'm going to ignore the plus c, because if I take the derivative of c, I just get 0, so it's gone. So we're just going to concentrate here, and we're going to do low d high, and the derivative of the high is 2/3 times 5x plus 1. Subtract 1 from 2/3, you get negative 1/3 times the derivative of the inside, because it's chain rule, plus 5 minus the high, 5x plus 1 to the 2/3 times the derivative of low, which is 2, all over the square of what's below. Wow. Okay. Now, if you look carefully, you will see that we have a common factor. So, oh wow, we have two common factors. If we also notice the 2. This is a 2, and this is a 2. So I'm going to factor out a 2, and I'm going to factor out a 5x plus 1 to the lowest exponent, which is negative 1/3. And I'm going to divide this into this. Well, this cancels, the 2 cancels, so I have 5 times a third, which is 5/3. I also have 2x plus 3. Minus. Now, when I divide this into this, you're dividing and the bases are the same, so you subtract the exponents, and 2/3 minus a negative 1/3. 2/3 minus a negative 1/3. Doesn't that become a plus? And so I have 2/3 plus a third, which is just 1. So this is just 5x plus 1. And then the 2 comes out because I factored it out. So the 2's gone. And it's all over 2x plus 3 squared. Now this is a negative exponent, so it can plop down here. So my next step, I'm going to realize that I have the cubed root of 5x plus 1 times the quantity 2x plus 3 being squared. And then in here, I can distribute the negative. If I distribute that negative over there, I have a negative 5x minus 1. I can distribute the 5/3. If I distribute the 5/3, I have 10/3 x plus, well, the 3's cancel, and I just have 5. So then adding these like terms up, 5 minus 1 is 4. And then 10/3 x minus 5x. Well, I'm going to have to change 5x to, let's see, 10/3 minus 5. That would be 15/3. That'd be a negative 5/3. So I get a negative 5/3 x. And then this 2 is still out here. Now that's a little messy. So maybe I'll multiply the top by 3 and the bottom by 3. So my final answer is 3 cubed roots of 5x plus 1 times 2x plus 3 quantity squared. And then 3 times this cancels, and I just have 2 times a negative 5x, and then 3 times 4 is 12, right? Yeah, 3 times 4 is 12. So have I verified it yet? Oh yeah, look at this numerator. Oh yes, I should have just left the 2 not factored, because 2 times a negative 5 is a negative 10. How about that? And then 2 times 12 is 24. And then the denominators are exactly the same. So check. This is the antiderivative of this. Math made simple. It's some math.